Hey, what's up guys? So in this video, we will talk about problem solving. If you have never solved a coding problem, don't worry. This video could probably help you solve some coding problems. I get a lot of messages from juniors asking about how to solve a problem, and I ask them all the same thing. Can you explain me the problem statement first? How would you solve the problem if you weren't thinking in terms of coding? And can you visualize what you're talking about? It may sound very simple, but it is quite hard. If you are finding it hard to solve a problem, why don't you take a pen and paper and try to come up with a solution? I know, it sounds pretty silly, right? Personally, even I have a bad habit of sometimes not solving the problem on pen and paper. I may get stuck at the problem for hours when I'm just thinking about the solution in my mind. But the moment I start writing on pen and paper, I may still find it hard, but I seem to be able to solve it faster. Now, why? That, I think, is because the solution I would have written or drawn explains the problem statement. When I look at it, I am actually looking at my own visualization and representation of the solution. So I believe that if a person can answer all these questions and explain the solution for it step by step, then they have actually solved most of the problem. And because the person is not thinking in terms of programming yet, they can explain the solution to anyone really. Now the only thing remaining is to write the code. Writing code is not as hard as it seems to be. All you need to do is explain the solution you thought of step by step, but in code. Because if you think about it, your code is just a representation of your mind, of what you're thinking about at the moment, which is why even variable names are important. Again, because it is representing what you're thinking of. Now, enough talking. You did get an idea. Why don't I show you how I do it? Alright, we will solve this lead code problem, but I have to tell you one thing before I do it. I haven't taken a look at the solution for this problem, but I still believe I can solve this problem. Why? That is because by practicing and writing a lot of code, I have trained myself to solve any type of problem. I'm not talking about particular data structures or particular concepts or algorithms. I'm simply talking about problem solving. I'm talking about the intuition of solving problems. That unfortunately comes only by solving problems and practicing the coding part. If you're doing something consistently, like let's say a sport, like playing a sport, you take a break and come back to it again, you'll realize that you have lost some touch. But if you start playing again consistently, your form picks up and you start playing great. It's the same with programming. You just have to maintain consistency and write code every day. Alright, let's solve this problem. It is an easy level problem. So if it takes time for you in the beginning, it's fine. No problem. Alright, let's read the problem statement. So we distribute some number of candies to a row of people in the following way. Okay, we give one candy to the first person, two candies to the second person, so on until we give n candies to the last person. Then we go back to the start of the row, giving n plus 1 candies to the first person, okay, n plus 2 candies to the second person, so on until we give 2 into n candies to the last person, okay. Till when does this happen? This procedure repeats until we run out of candies, okay, with us giving one more candy each time and moving to the start of the row after we reach the end, okay. The last person will receive all of our remaining candies, not necessarily one more than the previous gift, okay. Alright, so what do we return? We return an array that represents the final distribution of candies. And how would that look like? It would have length, number of people, and some candies, okay. Alright, so if you take a look at the lead code syntax, yeah, it's in Python, and your function would take your candies, number of people, and return the list. Basically, representing the final distribution of candies. Okay, let's go back to the problem again. Let's take a look at this part of the code. So, I mean, problem statement. We give one candy to the first person, two candies to the second person, until we give n candies to the last person. So, if you have one candy, um, your candy distribution initially will be 0. If you think about it, let's say a person is in front of you and you have to give a candy to that person. Initially, how many candies does that person have? It will be 0, right? But when you give one candy, what you are doing is you are giving one candy to that person, which will be number of candies he already has plus the candy that you give. So that would look like candy distribution of 0 plus 1. Right, now we can say that n is equal to 1, so you just replace this. Yeah, writing in terms of code, I think we can uncomment this. Okay, and yeah, we just have to return candy distribution, right? So let's go to our test case 1 and 1. So it looks fine to me. Alright, seems to be working fine. So what if you have 3 candies? So that would look like 3 candies should be given to 2 people. So how would you give? Let's say there are 2 people in front of you, you have 3 candies to give. Of course, looking at the problem statement, we can say that the first person gets 1 candy, right? And the second person should get 2 candies. So what happens to n? N is basically incremented by 1 because you move to the next person. So your person is also incremented by 1. Let's write it. That could probably help you visualize it. So your candy distribution into n, number of people, not n, sorry. Yeah, so in your case there are 2 people, so 0 into 2, yeah, this is Python stuff. So your array would look like 0 comma 0, and n is initially 1. So till when will you go on distributing the candies? Let's talk about that. That would be until you have no candies to give, right? So what I'm thinking right now is I can have, since I said until I have no candies, I am thinking of a while loop. While candies is not equal to 0, yeah, I don't want to maintain like indices like this, so I will say person is equal to 0. The first person, I'll represent him by index 0, and that candy I have to give to main, again n is equal to 1. Alrighty, so yeah, candy distribution, you will go on, you will give person, and so the first person gets 1 candy, your n will be equal to 1. So what happens to the total number of candies now? That should be decremented by 1, right? Because you just gave away a candy out of the 3. So your candies would look like candies is equal to candies minus n, because you give n candies. And now you have given 1 candy to the first person, and now you have to go on to the next person. So that would be person plus equals 1, person plus plus, and n will be incremented by 1. So yeah, if you try to return this, I think it will still work. Let's try. Yeah, I don't know why I have this. Okay, seems to be working fine. So, three candies and two people. Ideally, what else could you have? 10 candies for four people. So, 10 candies for four people, right? Let's see if it works. 10 candies for four people. Okay, seems to be working fine. But what if you have like 7 candies and number of people is equal to 4? It is not an equal distribution, right? Because if you look at the first example that they have given, number of candies is equal to 7, number of people is equal to 4. So the first person gets 1, second person gets 2, third person gets 3. So 3 plus 2 plus 1, which will be equal to 6. And now you have only one candy to give, which you will give it to the last person, right? So if you try to run the code, it will break. I'm hoping it breaks, obviously. Alright, it says list index out of range. If I was a newbie, I would probably have no idea what is happening. So what I would do is probably start tracing where it's all going wrong. So what do we have? Initially we have person is equal to 0, the first person, and you will give him one candy, right? So how would your candy distribution look like? So your candy distribution would look like 1 comma 0 comma 0 comma 0. Okay, and what would your total number of candies be? Since it is 7, total number of candies would be candies is equal to candies minus n, right, which will be equal to 6 at this point, right? So you do this, you go on to the second person. Your second person will be equal to 1. Okay, now what happens? N will be equal to 2, right? Because we are incrementing in line 11 and line 12. And your candy distribution will be equal to 1 comma 2 comma 0 comma 0. And your candies, what happens? It gets decremented by 2, so that will be equal to 4. Then you go on to the next person, which will be equal to third person. Yeah, how many candies should you give? 3 candies. Okay, what happens to the candy distribution? Yeah, said it right. So yeah, and your candies will be equal to 4 minus 3, which will be equal to 1, right? So this is the fun part. Then you go on to person 3. Okay, you give him n is equal to 4. Okay, so you give him 4 candies. So your candy distribution would be equal to 1 comma 2 comma 3 comma 4. Okay, and your candies will be equal to what? 1 minus 4, which will be equal to minus 3. Okay, my condition actually says that while candies is not equal to 0, so it should probably work even for negative numbers, right? So person is equal to 4, but is there a fifth person? So if I'm telling 0, I'm referring to the first person, by the way. So yeah, is there a fifth person? No, right? So what should the condition actually be? It will be equal to, while candies is greater than 0. Yeah, so if you take a look at this, it never goes to this, because once it becomes negative or 0, your while loop will break and you will return the candy distribution. So yeah, it should still be incorrect. Think why. Okay, so the reason is because 1 2 3 4 and 1 2 3 1, it is not matching with the expected, right? So yeah, what do? It's probably just a simple if condition, to be honest. If what if the number of candies that you have to give if the number of candies that you have to give is greater than n, then you could probably just execute line 9. But if the number of candies is less than expected, so that would look like candies is less than n. So if you have like one candy to give and your expected distribution is actually 4, then your if statement would look like candy distribution of person will be equal to candy distribution of person plus candies, right? Because if you have only one candy to give and your n is equal to 4 at this point, then yeah, just give one, right? It should be equal to 1 2 3 1. Otherwise, yeah, just candy distribution of person will be equal to candy distribution of person plus n. Now the question comes, what happens to the candy? So my first instinct will be that I will set number of candies to be equal to 0. Candies is equal to candies minus what? Yeah, candies. So it should be equal to 0. Now if I check, I think it will work. Yeah, let's try. Yeah, seems to be working fine. Then I go on, I'm looking. Yeah, I mean, even if it's negative, I can just break, right? So I will anyway break, I mean. So yeah, I could probably keep this out because it's the same in your while loop. Even if it's 0, it will break out. Even if it has negative integers, it will break out. So I don't even need this line, so I'll remove it. Okay, all right. So if we test this, yeah, seems to be working perfectly fine. So let's say the 8 people probably should have 1 2 3 2. Yeah, 1 2 3 2. But what happens when you have this part of the problem? Yeah, what happens when you distribute all the candies but you still have some left? Okay, then we go back to the start of the row, giving n plus 1 candies to the first person. Okay, all right. Looking at example 2, yeah, they have 10 number of candies, 3. So ideally, like in the first iteration, you have 1 comma 2 comma 3, so that would be equal to 6, and you have 4 candies remaining. Now how are you going to give the 4 candies? Okay, on the fourth turn, answer of 0 plus equals 4, and the final array is 5. Oh, okay. Yeah, I understood this. So yeah, what you do right now is that if you have any candies remaining at the end of the nth turn, then you go back to the beginning and distribute n plus 1 candies. So if you have 4 people and there are still some candies left, your n plus 1 at that point will be 5. So you have to go back to the start of the row. So yeah, let's talk about this. Candies is equal to 10 and number of people is equal to 3. Let's do this part. So person, okay, so yeah, I'm just going to erase this. Yeah, let's see what happens. I don't even need this, right? Because there are only 3 people. And what happens initially? What do you have? You have candies is equal to 10. What does it change into? 9, because 10 minus 1 will be equal to 9. Then your candies, so 9 minus 2 would be equal to 7. Then you go over to the third person, you have 7 candies remaining. You have to give him 3 candies, so your candies will be equal to 4. Okay, now you realize that you have distributed candies to 3 people in front of you, but there are still 4 candies remaining. Now what do? They say that go back to the start of the row, go back to the first person, give him n plus 1. So person is equal to 3, I mean 0, not 3. So yeah, you go back to the first person, give him 4 candies. So your candy distribution would look like 1 plus 4 comma 2 comma 3, and the candies you have remaining will be equal to 0, right? So yeah, what is this 1 plus 4? 5, 2, 3. Do you have any candies remaining? No. So you will break out of the while loop, you will return candy distribution. So yeah, it matches with this. So if I'm taking a look at the code, I will say that yeah, when person is equal to 3, right, which is equal to n, the number of people, then I set my what I set my person back to 0. So if person is equal to number of people, right, if it ever goes to the fourth person, I will set person back to 0, to the start of the row. Basically, if I was just saying it to anyone, I would say once you finish distributing to the row of people, go back to the start of the row, go back to where you started from, do it again. So yeah, even this, if you consider n plus 1, so 3 plus 1, and yeah, second person gets 3 plus 2, but we never come to that case. So yeah, I can probably test 10 and 3. Let's see what we get. Yeah, seems to be working amazingly fine. So yeah, now I am thinking of some cases. Let's say you have 24 people and 24 candies to be given to 5 people. What happens in that case? Yeah, okay. 7, 5, 3, 4, 5 matches with what we were looking for. So I can try to submit, I guess. Okay, it got accepted. Yeah, I thought I'll run into a few errors, but that's okay. I think my tracing helped what I was looking for. So I'll just remove this entire thing, obviously, and submit it again because it is satisfying. So yeah, we have solved the problem and submitted the code, which means it passes all test cases. So I'd say don't just stop there. Try to come up with one more solution or maybe some other approach. Try to refactor your code. Yeah, think about what is the time complexity. Can you tell in the comments? What is the space complexity? Can you think of another scenario where you would have to write some algorithm like this? As someone who is solving problems, this is what you could think about. So yeah, try to solve at least 2 problems a day. Sometimes it may take a day or two to come up with a solution, even for easy problems in the beginning. So that's perfectly fine because you are new at this. It would be helpful if you could solve the problem with a friend or anyone really. That is, discuss the problem and try to come up with a solution. I did the same. I connected with people and learned how to approach problems. rather than looking for a solution of that problem, which is what most people do. So yeah, I'd say that that solution would not be your own. So it would be helpful if you could find a mentor or a friend you could solve problems with. uh, Luckily I had both, so you could do the same too. But at the end of the day, your mind should be able to come up with a solution, which again comes from working hard and writing code every day. Eventually you will get to a point where you will love these challenges and want to solve more and more problems. I hope you do get to that point. Yeah, before I sign off, let's see if I can refactor my code. I could probably write this in one line, right? So candy distribution of person will be equal to candy distribution of person. Ideally, I would even remove this. It would actually be plus equals candies. This will also be plus equals um, plus candies. If candies is less than n, else candy distribution of, yeah, else candy distribution of person plus n, right? So maybe I can comment this code out, try to run. Yeah, seems to be working fine. I'll just delete this piece of code. Yeah, it's basically in one line I've written the whole solution, sorry. So yeah, I'll try to submit this. I've refactored my code. Yeah, even the runtime has improved, so yeah, that's quite an improvement. So anyway, if you like the video, make sure to leave a like and subscribe to my channel. I don't know when I'll be making another video or what I'll be making the video on. I have no idea. So until then, see you.